Alright, today we're gonna look a little bit more at this compiler, and I noticed something when I looked at the Odin documentation, which is that there is something called force inline, which I guess will force the compiler to inline this function or procedure. And I think that's pretty handy for these types of functions, which are being called a lot. We actually want them to be inline. Probably. But alright. The next thing we want to do is change this run function a little bit, because we don't want to print values all the time. We kind of only want to print them if some sort of debug flag is set to true. So the way we can do that in Odin is with the when keyword. So this is sort of like hashtag if in C. I'm basically just gonna think of it like that. So when the debug flag is set to true, it has to be a compile time constant and so on. When it's set to true, we print the value. And we can perhaps even do something better if we refactored this to print out some, like if we had a function to print out the current instruction, then maybe we would want to use that here. Let's maybe leave that off for now. Just have it like this. So now we can run it, and as you can see down in the bottom here, we are still printing the values, but if we set the debug flag to false, then nothing is printed. So that's pretty handy for when we want to debug it. Obviously we don't always want to print stuff out, but when we're debugging it, it's probably nice. Alright, so the way our virtual machine is going to handle values like this, it's not gonna print them out, but it's gonna push them to a stack, kind of similar to languages like assembly or Forth, I guess, that use stacks a lot. So when we read a value out, we're gonna push it to the stack, and then later some operation will consume it from the stack. So I was looking into whether there's like a built-in stack in Odin, but I couldn't find that, so we're just gonna make our own. We're gonna use quite an interesting feature, namely that we can have these compile time arguments to the struct. So for example, we're gonna say the capacity of the struct is this. It'll have an index, which is an integer, and then let's call it values, which will be an array of size n. I think that's the syntax, yes. And the type is value. Remember that value is this thing we defined ourselves. Where was it? It was in here, which later will be something more interesting, but right now it's just a float. So then we need things like a push, takes a stack and a value, and then basically, so this guy, let's say it points to top of the stack, and we can even do something different. Let's try to use pointers again. So it points to the top of the stack, and values of the stack. So then this code actually becomes a little bit annoying. So I think there should be like a pointer. There's the pointer offset. Pointer offset. Right, there's a pointer offset and there's a pointer subtract. So we can do like number of elements is equal to pointer subtract, and it's gonna be the top of the stack minus the start of the stack, and maybe we have to take the address there. Let's try this for now. And if the number of elements is greater than the length of the values, then we have a problem. And to solve the problem, I think we need a CoreOS. We're going to say Stack Overflow, and we're going to exit. Now, otherwise, stack.top dereferenced should be equal to the value, and then stack.top should be pointer offset stack top 1. So that's enough to test something now. We're gonna test it manually. Maybe later on we'll write some actual test code. But for now, let's just comment this out, and then we'll say, give me a stack, please. Now we have a stack pointer. Then let's try to push a number to the stack. And then I wonder what happens if we print the top of the stack and the values. Right, so we actually need to supply here how many elements we can have. Let's say 8 for now. So a couple of small problems. That one, stack of types pointer to stack 8 has no field value. That is very true. Stack of type pointer to stack has no field top. So maybe we have to do it like this. Right. Expected a pointer value for pointer sub got an array. Okay, so here we actually need to take this guy. Okay, so you cannot, so actually we have to take the first one, I guess. And undeclared name values. Go, and we got a segfault. Nice. It's possibly because these values are not initialized, so let's make a function that's called make stack, which will take an integer, has to be compile time constant, and it will return a stack. So let's say values is gonna make an array of values like so, I do believe. Then the stack is going to be a new stack, size n, and stack.top is going to be value 0 and the address of that, and stack values is going to just be values, and we can return the stack. Then maybe we should also have a delete stack procedure, which takes a stack and it will delete stack.values, and I think delete, and I think free the stack pointer. So now in main we should really say stack is a pointer to stack 8, and we'll make a stack size 8. And then we can defer delete stack. Let's see if that works. And here I forgot to say stack n. And it has to be n. Okay, so apparently there's not a make function for this. Maybe it works like that. No, it doesn't. But I also looked at the documentation, and they have an example where they are making an F32 array, which looks like this, which is weird for a couple of reasons. It's weird that there's no built-in function to do this. Actually, perhaps I can just say, maybe that's the point. Let's try to run that. Cannot assign a type. Okay. This is okay. I get it now. This is the type. So what if we do this? Apparently there's no delete for an array, and now we have Stack Overflow. It is indeed a lot. It's kind of weird though. Let's try to change the type a little bit. Is this possible? I don't think it is. But let's do it like this. So now we just have a stack. This will make a slice of this length. Delete stack, takes just a stack pointer. And in here, there's no such thing as a stack 8. Right. Okay, so that worked. That's interesting. I guess something happened to the data, the array data. Okay, I'm not gonna worry about that right now. Just get rid of that. So now we have a stack that we can push things to. We can probably say force inline here. That one can force inline. We take a stack, get a value. So we need number of elements. And if the number of elements is 0, we have underflow. But otherwise the value is whatever is at the top. And then we can subtract, I guess. Subtract 1, return the value. Okay, that didn't work. I think you're supposed to do like this. So that worked. So we print the top. Let's pop something. And there was an underflow. Which is weird. That's because this is supposed to be equals to 0. Okay, I guess I'm a little tired. Okay, so here's a problem. We actually need to do like this, because the top is pointing to the next element to be filled. So now when we pop, it's actually the right value. And now in the delete function, I do believe we can do that. Okay. So now we have a stack. And I think we're gonna put it in here, so rather in here. It's gonna have a stack, maybe we'll call it something else later. And this is make a stack of stack capacity, which we're gonna define here to be something like that. All right. Now there's a stack for the virtual machine to use. And I think the last thing I'm gonna do in this video is take this, put it up here, and put all of this up here. And this bounds checking, let's only do that if we're in debug mode. Like so. Because this kind of thing you don't want to do if you need speed, I guess. But all right, I think that's it for now. In the next video, we're actually going to use the stack to do something. So I will see you then.